Hey guys, welcome back to the Researcher Rubbish podcast, where we invite the authors of popular media articles and the researchers who wrote the research literature behind it. So today we have both articles centering around an alkaloid of the Amaryllidaceae family, which I'll just call the AM family for your sake, known as hemanthamine. The compound was originally researched by a team led by a man named Lafontaine due to the implications of other natural alkaloids in this family, such as narciclacine, on cancer. But a great promise of hemanthamine is that it is really highly water soluble, meaning that its bioavailability is greater than the other alkaloid in the family. Right, now that I've bored you, let's introduce you to our guests. So today on the podcast we have an unnamed author from Times Now News who wrote the article, "Scientists say daffodils may soon help cure cancer." Welcome.
Hey everyone, I just want to say I love this podcast. I love this so much that I brought daffodils to cure cancer.
Wait, that's not how it works.
So nice of you. And anyway, we also have Lafontaine from the University of Brussels in Belgium, who led the research team that wrote the research article, "The AM alkaloid, hemanthamine, binds a eukaryotic ribosome to repress cancer cell growth." So the role of our expert is just to check the media article for lies, truths, and sensationalism. Welcome.
Hello everyone.
So I thought we would begin with unknown author giving a brief description of his media article.
So my article was all about how daffodils can be used to cure cancer.
Actually, daffodils aren't used to cure cancer. The compounds in daffodils, which are also in other plants like hemanthamine, which I studied, are found in daffodils.
And cure cancer.
And cure cancer.
Yeah.
I did write later that other plants could be used too.
Oh, so why would you put daffodils in the headline then?
Because who doesn't love daffodils?
Anyway, to reiterate, this research is about the anti-cancer properties of the AM family alkaloids, which are found in the AM family.
Because they kill cancer.
Wait, no, we actually haven't proven that they can cure cancer. They just have cytostatic effects on cancer cells.
Okay, so same thing. Anyway, the compound, as you call it, prevents cancer in humans.
Well, actually, it hasn't been shown here. First of all, our experiment just showed the mechanism. It was a proof of principle about the mechanism of how it actually works, and that means that there's a long way to go in terms of proving how it should work.
Oh.
So hemanthamine binds to the ADS ribosome of the yeast model, which was what we showed. And what we also showed was that hemanthamine actually binds to the A site of the peptide transferase of RNA translation, and that stops the elongation phase.
All right.
Hemanthamine has strong physiological effects in humans. I read about that.
Again, there's no proof in humans. We showed this in mouse models, but we think that it might be activating the nuclear stress pathways via hemanthamine, and this is exploited by cancer cells, which blocks protein synthesis if we activate it.
Obviously, I wrote about that.
Well, kind of. It was kind of jumbled, and I didn't really understand what you meant.
Because it's obvious.
Okay, so what does nuclear stress mean?
That the nucleolus is stressed, and then boom, no tumor.
But yeah, where's your cause and effect? What? I don't feel like you understand what that actually means.
I mean, it means that the nucleolus needs to motivate more.
Nuclear stress is a failure to create ribosomes.
Ah, yes, I wrote about those. They're really good nanomachines.
They're not nanomachines, they're biological organelles, okay? There's a good metaphor to describe how they work, but it doesn't actually what they actually mean. You're just confusing everybody about that. It's complicated, but hemanthamine binds to the right parts of the ribosome, and that stops peptide bond formation, which in turn stops protein production. And that's the function of the ribosome, right? So that also stops the function of the ribosome itself. It can't be created itself. And so what happens is these ribosome components get accumulated, and then that binds to HEM2, which is involved in the ubiquitylation of P53.
Oh, that's amazing. So basically, for anyone who didn't get it, ubiquitylation is the body's way of tagging cells that need to die, and HDM2 is a molecule that's involved with that and promotes this effect. So if HDM2 is captured, then it can't tag P53, so P53 won't be broken down and can enact its own function.
Which finally brings us full circle, as P53 is a tumor suppression gene, right? And that's involved in apoptosis and DNA damage.
Oh, so that's the anti-tumoral surveillance I wrote about.
Yes, so it's actively looking out for damaged cells so you can stop it.
You are a genius.
Thank you.
Right, so I feel I can fairly give the researcher rubbish rating. So for our expert, your research is incredible. And even though I can understand there's a long way to go, as stated in your article's conclusions, your proof of principle experiment completely demonstrates how hemanthamine binds and how it can be useful for cancer treatment. The media article, though, was rubbish. Metaphors were used to simplify explanations but had no depth. So if readers that had little or no scientific knowledge were reading it, I don't feel like they'd be able to follow along. And furthermore, your article completely sensationalized Lafontaine's research, and you admitted that yourself, saying that daffodils can be used to treat cancer, and claiming that it has effects in humans. Right, so that's all, folks. Thank you to our guests and our listeners at home. We hope you enjoy the Research Rubbish podcast for this week, and we hope to see you again next week.